Hello friends. Let's discuss about binary search. So it is one of the searching algorithm which is performed in the time complexity of login. In binary search, what happens is we divide our array by using a mid index into two, and we search that if that particular array element is less than that of my key or greater than that of my key. If my key means what, which element we want to find in the array. So if my key means which element I want to find in the array is less than that of the mid element, then I split the array into two and I search on the left side of the array. And if it is greater than that of the middle element, I search on the right side of the array. So on, so we will have to do in such a manner unless and until we get one element in our hand, and that is the last case of our binary search. So first discuss about what is the time complexity of this algorithm. So we have n elements, for example 1 2 3 up to n elements, and we recursively divide this by 2, means we split it into for equal halves. So at each time we divide it by 2, 2 to the power 1, 2 to the power 2, 2 to the power 3, so on, so up to 2 to the power k, unless and until we get one element. So mathematically, if we equate this, n divided by 2 to the power k is equal to 1. And to find out what is the value of k, we have to take log on both sides. So log n by 2 to the power k is equal to log 1, log 2. So 2 is log 2 to the base 2 is 1, and k is equal to log n. So that's how we find out the time complexity of this binary search. So let's code the binary search. It is very simple code. First we have to create function. In that function we have to take array. There are other three more parameters, that is low, because we want to know about what is the lowest index and highest index. Otherwise we can't solve this recursively. We have to go iteratively. So that's why I take here in parameter low and high. And the last parameter is a key. Key means which element we want to find out in that particular array. In that array, which element we want to find. That is our key. So first declare mid, which we require as an index, because we, by using that index, we split the array into two equal halves, or halves, maybe equal or not. So that's it. So if low is less than equal to high, then we have to declare mid, that is low plus high divided by 2, because we split it into two half. So if a of mid means my middle element is equal to key, then we have to return the index of that particular element, whether we find that element or not. So that is mid, that is index. Else if key is less than a of mid, means our key is on the left hand side of that particular split, then we have to return recursively, recursive call we have to take care here, a comma low as it is, but as we split the array into two, our high is mid minus 1, and key as it is, key doesn't change, so key as it is. And if it is greater than, if my key is greater than my a of mid, that is my mid element is less than my key, then we have to simply return binary search a comma, here low is my mid plus 1 and high is as it is and key is as it is. So that's it. This is the simple code. And if low is not less than high, means my indexes are wrong, and if indexes go gone through each and every iteratively each and every index, and if low is greater than high somewhat, then I have to return -1. That means my element is not present in that particular array. So let's check this code whether it is correct or not. So I take one array of size 10, then int p is equal to binary search. I have to pass array, then lower index is 0, higher index is 7, higher index is 5, and the key which I want to find is 20, and cout p. So let's check that it gives us index as 1. So as you see on the screen, the index given is 1. That means our code is run successfully. The logic is very simple. There are other sorting algorithm also. In upcoming videos, I'll download all the videos with board. So that's it. Stay blessed. Thank you.